Hello and warm welcome to one and all. Myself Vinayak K. Sonar, science teacher, Minority Morarji Desai Residential School, Karjigi, Taluk District, Haveri. Student, today we are going to study about some basic concept of electricity. We seen so many electrical appliances in day-to-day life like light, TV, fan, refrigerator, washing machine, induction cooker, CD player, micro oven, hair dryer, computer, mobile. So many electrical equipments you are using and seeing day to day life. But student, do you know how electrical current do work in these electrical appliances? No? Then let us start to learn how electrical current do work in these electrical appliances. Student, in the universe, all the matter is made up of atoms. Similarly, the good conductors like copper, gold, silver, aluminum, all are made up of atoms. This atom consisting of three subatomic particles in that two are present in the center of the atom that is called nucleus, and they are one is the proton, it is a positive charge particle. Another one is a neutron, that is chargeless particle or no charge. And remaining one is revolve around the nucleus, that is called electrons. It is negative in charge, and these electrons are revolve around the nucleus in a circular path as the planets are revolve around the sun. Student, in these electron there are two types of electrons. One is innermost electrons. These electrons are present in a completely filled cell, and they are tightly bonded by the nucleus. And another one type is called the outermost cell electron, are also called valency electrons. They are not so bonded with the nucleus. And let us see the electronic configuration of copper. You get confused because you expect this type of electronic configuration according to Abu principles. Abu principle tells first least energy orbital is filled, then fill the higher energy orbitals. Student, if you fill like this, then 4s is completely filled and 3d will be partially filled. But according to Hoon's rule, the completely filled and exactly half filled electronic configurations are more stable. Student, due to that, the copper attain this electronic configurations because in these configurations these 11 electrons are occupied in a systematic manner, in a complete and exactly half filled manner. If you see this d orbital is completely filled and all electrons are occupied, and this completely filled orbital is more stable. And if you see the 4s, this is exactly half filled, and therefore half filled and exactly filled electronic configuration is more stable than what the partially filled orbitals. So copper will attain this electronic configuration. In this electronic configurations, the one electron will be present in the fourth cell. The last cell electrons are called valency electrons. The last cell electrons are called valency electrons. Student, these valency electrons are free to move and they are loosely bonded with the nucleus, so they are easily um, removed from the it will easily removed from the copper in by very short temperature, like thermal energy of metal. This electrons, when this electron is removed, then that copper will become the copper ion. Copper will become copper ion, and this electron will be released out, and it is free to move in that metal. These free electrons carries negative charge, and this copper will carries the positive charge. And let's see this figure number 1. This is the expanded form of copper wire without connected to the battery. If you see this expanded portion of copper wire, you will see two particles. One is blue in color, that is free electron, and it is red in color, that is copper ion, that is positive charge. If you see the blue color particle and their arrowhead, this indicate that all free electrons are randomly moving in all directions. Student, if this wire is connected to the negative terminal of the battery as well as positive terminal of the battery, then the free electron in wire are uniformly arranged and start moving towards the positive charge, because these blue color dot free electrons are carries negative charge, and they are repelled by the negative terminal of the battery and attracted by the positive terminal of the battery. So they are moving towards the positive terminal of the battery. Here the electrons are flowing or moving towards the positive terminal of the battery. Student, let's see, this is a circuit. This is the symbol of battery. It is also called source of electric current, and this is the bulb, or it is the resistance. When the wire is connected to the negative terminal as well as positive terminal of the battery, the electrons are start to moving in uniform directions toward the positive charge. We discuss the concept of electric current based on flow of the electrons, but in initially this concept is little bit changed. That is called conventional methods. Initially scientists think that the flow of positive charge the flow of positive charge is called the electric current. Later on the scientists come to know the flow of the electron is the electric current, but still now we are using the flow of charge as a electrical conductor. Still now we are using this term, the flow of charge, positive charge is called the electric current. Student, let's see the definition of electric current. Electric current means it is the rate of flow of electric charge in a circuit per second. Means, student, how many charges are flowing through the circuit in a second. How many charges are flowing through a circuit in second. That is called electric current. For example, student, if you take any part of the or any point of the circuit, zoom it and see it, how many charges are flowing in a circuit towards the negative terminal of the battery in per second. that will gives the electrical current. Student, what we are using nowadays, this charge concept or the flow of charge concept, that is the conventional method. But the actual concept of electric current is the flow of electrons. The flow of electrons from negative terminal negative terminal of the battery negative terminal of the battery to the positive terminal of the battery. uh, Means electron travel from negative terminal of the battery towards the positive terminal of the battery is called electric current. Means how many electrons are moving from negative terminal to positive terminals. Always student, the conventional flow of current means flow of charge is exactly opposite to the what the actual concept of electric current, the flow, that is flow of electrons. Means if the flow of electron, if flow of electron takes place from negative terminal to positive terminal, this is flow of electron. And if the charges are flow from positive terminal to negative terminal of the battery, that is the flow of charge. Both are opposite to each other, student. This is negative to positive, flow of electron, and positive to negative, this is flow of charge. Both are exactly opposite to each other. Student, I will give one similarity to the electric current. I hope all of you see the vehicles are traveling on national highway. How many vehicles are traveling on national highway in per second? That is the vehicle current. Student, this is not actual uh, concept. Means I am giving the similarity. If you see the number of vehicles traveling on the national highway, that is the vehicle current. Means what we studied, number of charges traveling or flowing in a circuit, that is called the electric current. And here how many vehicles are traveling on a national highway, that is the vehicle current. This vehicle current is measured by the toll center. This vehicle current is measured by the toll center. Similarly, the similarly the flow of current is measured by the ammeter. The flow of current is measured by the ammeter. This is always connected to the series. Always connected to the series. Always connected to the series. And you see the mathematical expression of current here. Means I means the current, Q means it is the number of charges, T means it is the time. How many charges are moving in a circuit in 1 second, that will give the electrical current. Very simple, student. How many charges are flowing in per second, that will give the electrical current. That will be measured by the ammeter. Student, I will give another one similarity. This ammeter work and the water meter work, both are similar. This ammeter will measure how many charges are flowing in a time or per second. How many charges are flowing per second, that will be electric current. That electric current is measured by the ammeter. Ammeter, student, very important, student. The flow of charge per second, that is called electric current. This electric current is measured by the ammeter, students. Similarly, if you see the water meter, the how much amount of water flowing through the pipe per second or per time, that is the water current, student. That water current is measured by water meter. Simple it is. Means the ammeter work and water meter work both are in similar. Ammeter will measure the flow of charges. Water meter measure the flow of water. Both the work is similar, student. What is meant by 1 ampere? Student, charge is measured in coulomb and time is measured in second. 1 ampere means, student, 1 coulomb of charge flowing in a circuit per second, that is called 1 ampere. Simple, student. 1 coulomb of charge flowing in a circuit in 1 second, that is called 1 ampere. This is measured in ammeter. Nowadays we are using multimeters. This multimeter not only measure the flow of current but also the other parameters. Student, I hope you get the idea of flow of current. Now we see what is the work or what is the influence of battery in circuit. The battery consisting of two end, student. One end is called anode, that is negatively charged, and another end is called cathode, that is positively charged. In this battery, due to the electrochemical reaction, due to the electrochemical reaction, the electrons are get accumulated at the anode. Means this anode will be electron rich due to the electrochemical reactions, and cathode will be the electron deficient, means there is least number of electrons. Due to the electrochemical reaction, this anode will be the electron rich center and cathode will be the electron deficient center. Here, student, anode wants to give the electrons and cathode wants to receive the electrons, but there is no direct way to give the electron to the cathode because there is an electrolyte. Due to that, if we connect the wire to anode to cathode in presence of any resistance, it may be the bulb or any electric appliances, the anode give the force to the electrons present in the wire to move forward, because this electron are negatively charged and electrons present in the wire also negative charge. Due to that, the anode pushes the electrons toward the positive terminal. What makes to flow the electrons here, student? Student, here this anode is electron rich center and cathode is electron deficient center. Due to this electron potential difference, the electrons start travel from negative terminal to positive terminal. When the potential difference, means number of electron in the anode and number of electron in the cathodes, are equalized, then the cell will be dead. cell will be dead, then the bulb will stop. Therefore student, in this slide you have remember the potential difference of electron or electron potential difference cause the flow of electrons. Means, what is mean by electron potential difference? There is difference in the number of electron in negative terminal and number of electron in the positive terminal. Here electron number is least, here number of electron is rich. Therefore higher concentration means higher number of electrons to lower number of electrons, the electrons will be travel. This is very important student. Now see, here is one example. This is a fountain system. This is one a fountain system. In this fountain system, on the earth there is one fountain. Underground there is one tank. In that tank there is a submersible pump. There is one a submersible pump. And this submersible pump is connected to a thin pipe. It is connected with a thin pipe. And another, the fountain sprinkle the water. The sprinkled water again collected in one pond, and that pond is again connected by a thick pipe. Here the submersible pump will create a high pressure on water. Means high submersible pump will push the water to upward in this thin pipe. Means here creation of high pressure. This reason is creation of high pressure. Student, are you understanding? Here the pump, submersible pump, pushing the water means pressurize the waters, means it is pushing the water upward means here the pressure is more. This reason is pressure is more. And when the water is coming out from the fountain, it is sprinkled out and it is collected in the pond, and here is a thick pipe. This is a lower pressure reason, means there is least pressure on the water, and again it is coming down to the lower potential reason. In this water cycle, this is one water cycle, means the pump will pushing the water in a thin pipe, and the fountain sprinkle out the water, and again it is collected in the pond, again it is coming through the thicker pipe and collected in the tank. This is a one water cycle. Student, here you see this pipe, this pump will pushing the water, means here the creation of pressure difference. This pump he is doing the creation of pressure difference, means it is pushing the water, means it creation of higher pressure, and when it is come back to the ground state, it is creation of the lower pressure regions. Means due to this difference, here pressure difference, due to this pressure difference, the water is in a cycle. Student, here is one question: what makes the cycle, what makes to retain the cycles? Means here this difference make the cycle to continue. Similarly student, if you see the electrical circuit also, it is similar to the what the water cycle. Here student, what the submersible pump doing, similar work is done by the battery. Here the negative terminal is electron rich and the positive terminal is electron deficient. Due to this electron rich and electron deficient, this is the difference, electron difference. This due to this electron difference, the electron star or start to flow from negative terminal to positive terminal. This electron difference is made by the battery, student. This is very important, student. The potential difference, electron potential difference, makes the electron to flow in the circuit. Student, both the pump and battery will do similar work. Let us see the definition of voltage. Student, already we know that the potential difference. If the potential difference is created at any place, there is a creation of force. That force will give the energy to move the particle from one place to another place. This is very important. When there is a creation of potential difference, then there is a and when there is a potential difference is created, there is a generation of force. That force gives the energy to move the particle from one place to another place. Here also, if a potential difference is created between 2 points, then 1 joules of energy is utilized to move 1 coulomb of charge from one place to another place. Student, very simple, student. Here potential difference is created in the battery, created by the battery. Means it is the negative terminal, this is the positive terminal. This is electron rich, this is electron deficient. This potential difference create the force in the anode. This force give the energy to the electrons to move from one place to the another place. If 1 joule of energy pushes the electron, then 1 coulomb of electron will travel from one place to another place. Then it is called 1 volt of current. I hope you get this point, student. Means if the potential difference is created at the anode, then there is a force created at the anode. That force give the energy to move the electron from one place to another place. This is called voltage, student. Student, if the potential difference is increase, means more the potential energy, more the potential energy, then more number of electrons will be moved. If the more number of electrons will be moved, then there is the brightness of the lamp. If you place the resistance, or if you place the lamp or any electronic appliances, their work will be very rapid. I will explain in next term. Means here you have to learn, if more the voltage, then more number of electron will be flow, then more work will be done. Okay, students. Next, you will see here is another one slide. Here, this is the tallest dam. This is medium or the smallest dam. Here, in the tallest dam, the flow of water is more, as well as the kinetic energy is also more. Means speed of water is also more and amount of water is also more. Why? Due to the potential energy difference. Here potential energy difference is less, therefore the flow of water is less, kinetic energy of water is less. Student, let's see the how to represent voltage in a mathematical form. You can write two way to represent the voltage. One is for the electrical appliances, another for the battery. With respect to electric appliances, when 1 joule of work is done by the electric appliances when the 1 coulomb of charge flow from one point to another point. Means in time of when electrons or charges flow from one place to another place, at that time if the electric appliances did 1 joule of work, then it is called 1 volt. Or with respect to battery, when 1 coulomb of charge traveling from one place to another place, that utilizes 1 joules of energy, then it is also called voltage. If battery utilize 1 joules of work to travel 1 coulomb of charge from one place to another place, then it is also called 1 volt. If the electrical appliances do the work of 1 joules of work when the 1 coulomb of charge travel from one place to another place, this is called the voltage, 1 voltage. Student, I hope you got the idea of electrical current and the voltage. Electrical current nothing but the flow of the charges. Voltage nothing but the pushing force to flow the charges from one place to another place. Student, we will discuss the last term of this video is the resistance. This resistance is exactly opposite to what the electric current. Resistance means it is the ability to slow down the electrons. Means the flow of electron will be slowed down. That ability is called the resistance. For examples, I will give one example here. If the water is flow through a normal pipe, then normal quantity of water you can afford. If the water is flow through the pressed or compressed pipe, then there is a hindrance of water coming out, then the flow of water will be slow. And I will give another example here. You have the experience to ride the bicycles. During the ride of bicycle, you feel the air is pushing you backward directions. Means air is resist your motion. That is also called resistance. Means air is resist your motions. That is also air resistance. Or if you walking, or if you jogging, or if you running in open air, then also you feel the resistance of air. Student, this resistance is measured in ohms. This resistance is measured in ohms, and symbol is this is. And what is meant by resistance? Resistance nothing but how much current is slow down. Means how much current is slow down, means how much flow of electron is slow down. That is called the resistance. Bigger the resistance in the wire, smaller current will be flow. Smaller the resistance in wire, more current will be flow. Then we'll see what are the factors affecting the resistance. If the length of the wire is larger, then resistance is more. If length of the wire is less, the resistance is less. For example, I will give one example. If you are riding the bicycle in a rough road of a longer distance, then you will get easy tired. Then resistance is more. If you ride the bike or bicycles in smaller distance rough road, then you will less tired. Resistance is less. Then second quantity is area of cross sections. Means thinner the wire, more the resistance. Thicker the wire, less resistance. I will give one similarity for this. If in your school there is one function taking place in a function hall, and that function hall has the smaller door, then there is a sudden explosion takes place, then that crowd will moving towards that door, but the door is very small, then there is the crowd, resistance will be increases, the outcome of peoples will be less. Instead of small door, if you fix larger or broader door, then more number of peoples come out, then resistance will be less. Therefore, thicker the wire, resistance is less. Thinner the wire, resistance is more. And this resistance is also depend on the material. If the material is good conductor, then less resistance. If the material is bad conductor, then it is more resistance. Means you are traveling in the tar road, then resistance is automatically less. If you are traveling in the rough road, mud road, then automatically the resistance is more. Similarly, student, if the temperature increases, then resistance increase. If temperature decrease, then resistance will be decrease. Student, this is way the resistance, current are opposite to each other. Student, I hope you understand these concepts. Student, I will increase your understanding level by giving these three terms with the relation of these cartoon. Student, here in this picture, the rabbit and rabbit childrens are moving in this hole. This movement is called a current or electric current. And to move these electric current, there is a force is given by the mother rabbit. Force is given by the mother rabbit. This force given by the mother rabbit is called voltage. And what the jackal is pulling out these small rabbit from the hole, that is the resistance. Means it will resist or it will hinders the motion of the small rabbit. This is what the current, voltage and resistance are related to each other. Similarly, here also the voltage is pushing the person, the ampere is moving towards the path, but ohms means the resistance is stopping the flow of persons. And here also here is one tank. In the tank, the due to the gravitation force pushing the water down, that is the voltage, and water is traveling in the pipe, that is the current, and there is a stopping knob, that is a resistance. This is how these three terms are related to each other. I hope you understand. Okay, thank you one and all. Thank you very much.